So we are starting a new chapter, sixth chapter in progressions, and interesting chapter, and of course new chapter. So let me give some introduction about this. See, it is nothing but the chapter dealing with numbers. So I will give few examples and then let us come to know what is progression. See, suppose if numbers are arranged according to a particular rule, any rule. So numbers are arranged according to a particular rule. For example, 5. Suppose 3 is added. 8, 11, 14, 17, 20, 5, 10, 20, 40, 80, 160. If you observe these numbers, what is your conclusion? If you look at this, these numbers are formed according to a particular rule. The rule is 3 is added, 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14, 14 plus 3, 17, 17 plus 3, 20. That means all the numbers are connected with a particular rule. The rule is 3 is added. Here also if you observe, you can tell the next number. If you look at this, you can tell the next number. The rule is multiplied with 2. 5 2s are 10, 10 2s are 20, 20 2s are 40, 40 2s are 80, 80 2s are 160. Like that, it is multiplied with 2. So like that, if the numbers are formed according to a particular rule, a particular formula, then this series is called progression. The numbers which are formed according to any rule, but depends on the rule, we have different names. In our textbook, we have 2 names. If something is added, if the numbers are formed by adding something, this is called arithmetic progression. That definition I will give. If numbers are formed according to multiplication, this type of series is called geometric progression. So we have only 2 types in our chapter: arithmetic progression and geometric progression. Progression means the sequence of numbers, the set of numbers. The numbers are formed according to a particular rule, any rule, then it is called a progression. If the rule is something is added, then it is called arithmetic progression. So write down the chapter name, and students, first you write down side heading progression. Write down. First chapter name, a small definition, progression. Write down. The series of numbers which are formed. The series of numbers which are formed according to uniform law or uniform formula, uniform rule. The series of numbers, the set of numbers, or the occurrence of numbers which are formed according to uniform rule. A rule, any rule, they will have same. That means number to number rule should not change. Suppose 3 is added here, then suppose if you add 5, it is not a particular rule. So 3 added means 3, 3, 3, 3, 3. Same rule should be applicable for all the numbers. So according to uniform rule, uniform means same rule. The series of numbers which are formed according to uniform rule are said to be in progression. The series of numbers which are formed according to a uniform rule are said to be progression. Now, in this entire chapter, maybe 4 to 5 exercises. So, we have only two types of progressions. One is arithmetic progression and second is geometric progression. Now, for the first 3 exercises, we are going to study only arithmetic progression. So, that means in this chapter, again it is divided into 2 parts. Now, we are going to the first part. Right now, arithmetic progression. Write down the heading arithmetic progression. Arithmetic progression. Already I explained, if the numbers are formed according to some addition, same number is added 5, 8, 11, 14, 17, 20. So, except the first term, each term is obtained by adding some constant term to its preceding term. This is called preceding term, this is called succeeding term. So, before term is called preceding term. How we are getting 8? Adding some number to its preceding term. Something is added to 5, that means 3 is added to 5 to get 11. 8. How we are getting 11? Something is added to this. 3 is added. Like that, if something is added to the previous number, we are getting the next number. So that is the definition of arithmetic progression. The arithmetic progression means all the numbers are obtained by adding something, some constant term to its preceding term. Adding constant term to its preceding term. Write down definition. Write down the definition of arithmetic progression. An arithmetic progression is, write down the definition. An arithmetic progression is list of numbers. List of numbers. That is list of numbers. Arithmetic progression is list of numbers in which, how the numbers are found, in which each term is obtained by adding a constant term to its preceding term. In which each term, write down, each term is obtained by adding a constant term to its preceding term. Preceding means before term. How we get 14? 3 is added to its before term. Before term is also called preceding term. Right? Preceding. But how this is formed? It is not formed by adding something to its previous number. It will be known. Except the first term, all the remaining terms are obtained by adding something. Preceding term, except the first term. This is a small definition for the arithmetic progression. You can write, and you can write example. An arithmetic progression is list of numbers, set of numbers, series of numbers, list of numbers in which each term is obtained by adding a constant term to its preceding term, before term. Something is added to except the first term. Right. Write this example and another example. 7, suppose if 5 is added, 12, 17, 22, like this. Suppose 5 multiples 5, 10, 15, 20, 25. This is also arithmetic progression. Because what is the difference? 5. Any two different terms difference will be always same. Right. Write the example. Write the examples for arithmetic progression. Difference is always same. 8 minus 5 is 3. 11 minus 8 is 3. 20 minus 17 is 3. 25 minus 20 is 5. 20 minus 15 is 5. The difference is always same. Write down continuation. In this, the constant term, I will write it. See, I just now told that something is added. How I am getting 8? 3 is added. 5 plus 3, 8. 8 plus 3, 11. 11 plus 3, 14. The 3 is added. That 3 is called common difference. Difference, you know generally, it is not a new word. Difference, that is called common difference. So whatever term I am adding, the 3 I am adding to each to get the next term. That 3 is called common difference. So in this, the constant term, write down, continuation, is called common difference. Common difference. Here this is 3 is a common difference. Here 5 is a common difference. Here 5 is a common difference. 20 minus 15, 25 minus 20, that is the common difference. Right. In this, the constant term is called common difference. Then write this example. Then another concept I will explain. See here, suppose first term is 10. Say the difference is, for example, 5. Difference is 5. Then what is the next term? Tell me. 15. Difference 5. Next term 20. Difference is 5. Next term 25. Next term 30. Like this. Difference is 5 means adding 5 we will get to see this. Suppose first term is A. Difference is D. Then what is the next term? Difference is D. A plus D. Again add D. A plus 2D. Again add D. A plus 3D. So general form of arithmetic progression is like this. First term will be given. Suppose if difference is D, what is the second term? Add D to this. A plus D. Again add one more D. Next. D plus D. 2D. Add plus D, 2D plus D is 3D, like that. Right. Second point, let A be the first term. In arithmetic progression, the first term is always denoted by A. First term is denoted by the symbol A. A be the first term. And D be the common difference. The common difference, the term which is added. Let A be the first term, D be the common difference. D be the common difference of an arithmetic progression. So now onwards, arithmetic progression I will use the short form AP. Arithmetic progression short form I will use AP. Then it is, what is the general form of arithmetic progression? First term is A, D is the common difference. Then how to get the next term? A plus D. Again add D, A plus 2D. Again add D, A plus 3D. So on. This is the general form of arithmetic progression. So this is the basic which I explained for the arithmetic progression. First term will be given, difference will be given. You can write any number of terms. So based on that, we have first exercise, only basics, only this much concept. So let us complete the exercise, and after that we will come to know. But in this series, suppose if the series is 5, 10, 15, this is the series. So this is the first term, second term, third term. What is the 15th term? What is the 15th term? You can write 20, 25, 30, 35, like that you can find the 15th term. But without writing all this, directly we have a rule for finding the 15th term. Then all we will study for the second exercise. As of now, for the first exercise, this concept is sufficient. Students, all of you open your textbooks and start the first exercise. So all of you open your textbooks and see the 6.1 exercise. Exercise 6.1. Okay, exercise 12.2 seventh problem, but already I started this chapter. Tomorrow, first problem I will explain, because already I started this chapter. Now there will be some disturbance again. I will explain. Exercise 6.1. First one. First bit. Minimum taxi fare is rupees 20 for the first kilometer and thereafter 8 kilometers for each additional kilometer. See, actually no solution, just you have to tell it is a arithmetic progression or not. That's all. Just reading the. So, in which of the following situation does the list of numbers involved make an arithmetic progression? That's all. Is it arithmetic progression or not? Just we have to tell. See here. First 1 kilometer, the taxi price is 20 rupees. We are traveling. Suppose we travel 10 kilometers. First 1 kilometer, what is the taxi price? 20 rupees. And each additional kilometer, 8 rupees will add. That means first 1 kilometer 20 rupees. Second again not 20. 20 is the initial one only for 1 kilometer. After that every kilometer 8 rupees. So next is 28 rupees. 2 kilometers. 3 kilometers again 8 rupees added. 36. 4 kilometers 36 plus First kilometer 20 rupees. Next kilometer 20 plus next kilometer 8 rupees, 28 rupees. Next kilometer again 8 is added, 36. Next 8 is added, 44. 44, 8 is added, 52, like that. So write down some explanation. Here some explanation I am giving. Here first kilometer cost is 20. First kilometer cost is 20. And thereafter rupees 8 for each additional kilometer. Thereafter, same question I am explaining. Thereafter rupees 8 for each additional kilometer. Here A is equal to 20. Each additional kilometer 8 rupees. Difference is 8. How I am getting the second one? Adding 8 to this, 28. Adding 8, we are getting this. So each kilometer 8 rupees is added. So therefore it is perfectly arithmetic progression. This is A. Write down. Here A is equal to 20 and D is equal to 8. The list of numbers. Actually, no, you are writing all this. Just whether it is AP or not, just we have to write. But I am giving numbers also. First kilometer, if we travel first 1 kilometer, we have to pay 20 rupees. If we travel 2 kilometers, first 20 plus additional 1 kilometer, no, 8 rupees. 28 rupees we have to pay. If you are traveling 3 kilometers, 28 plus 8 rupees, 36. If you are traveling 4 kilometers, 36 plus 8 rupees, 44. 44 plus 8 rupees, 52. Like that it will continue. So, right. This is AP. This is perfectly arithmetic progression because it is very clear. I gave the definition of arithmetic progression. First term will be given. After that, numbers are obtained by having same difference. 28 minus 28, 36 minus 28, 8, 44 minus 36, 8. Like that, 8 difference. Why 8 difference? Because each kilometer 8 is added. This is an 8. That's it. Same model, I will explain third one. Digging first 1 meter 150 rupees. First 1 meter, what is the cost? 150 rupees. Third bit. If we dig the first starting 1 meter, we have to pay 150 rupees. After that, every 1 meter, it is not same cost. First 1 meter only 150 rupees. Because some preparation, something they have to do. First 1 meter, then we take 150 rupees. After that, every 1 meter 50 rupees extra. So suppose if we are digging 2 meters, first 1 meter 150 rupees, next 1 meter is 50 rupees only. So total 200 rupees we have to pay. Suppose if we are digging 3 meters, 2 meters 200, another meter means 50 rupees added, 250. Again another meter 300 rupees. Again another meter 350 rupees. Like that. Difference is same. Every 1 meter 50 rupees added. First time 150 rupees we have to pay for 1 meter. After that again another 1 This is perfectly AP. Because first term is 150. What is the difference? How much is added each time? 50 is added for each meter. Second meter, 50 added. Third meter, 50 added. Fourth meter depth, 50 added. Fifth meter depth, 50 added. This is an AP. Write down. Here, A is equal to 150 rupees. First 1 meter 150. The difference each meter 50 rupees. You write down this list also. If you are taking first 1 meter 150 rupees cost, again another meter 50 rupees adding, 50 rupees adding, 50 rupees adding, like that. This is an AP. Here it is an addition. See here, suppose, just I am giving an example, second problem. In a cylinder, suppose air present is, for example, 400. Air present in the cylinder